Imagine walking through a doorway, just like the one in your home. But instead of stepping into another room, you step into a completely different universe. Not a metaphor, not science fiction, but something our physics actually allows. Wormholes, these mysterious theoretical tunnels in spacetime, have been a darling of sci-fi movies and late-night discussions for decades. But the idea that you could enter one and never come back isn't just a plot twist. It's a genuine consequence of Einstein's general relativity, with all its mind-bending implications. Now, think about this: you're floating in space, and suddenly this shimmering vortex appears in front of you. No sound, just the quiet hum of the universe. What would you do? If stepping inside could take you to a distant galaxy, another dimension, or even another point in time, would you go? And if so, could you ever return? We talk about space travel like it's about rockets and fuel, but wormholes open up an entirely different way of moving through the cosmos. They're not like highways across the stars. They're shortcuts through the very fabric of reality. But what does that even mean? Imagine folding a piece of paper so the ends touch. A wormhole is the tunnel that connects those ends, allowing you to skip the long journey in between. Sounds convenient, right? But nature doesn't hand out shortcuts without a price. The moment you cross the threshold, you're at the mercy of physics we don't fully understand. Regions where time may flow differently, where gravity stretches the rules, and where causality itself might unravel. And here's the real kicker. What if the wormhole closes behind you? What if the return trip was never guaranteed in the first place? You're in a universe that's not yours, with no GPS, no guide, no rescue mission. It's like stepping into a book where the last page is missing. Would your atoms survive the trip? Would you still be you on the other side? Or would you become something else entirely, shaped by the unknown laws of an alien cosmos? These aren't just fun questions. They strike at the very heart of who we are as explorers, as thinkers, as beings trying to make sense of a universe that seems to grow stranger the more we learn about it. All right, let's roll up our cosmic sleeves and make sense of something that sounds like pure fantasy, but is actually buried deep in the equations of physics: wormholes. To start, we need to understand that space and time aren't just empty nothingness. According to Einstein's general theory of relativity, space and time are woven together into something called spacetime, and that fabric can bend, stretch, and even twist under the influence of mass and energy. Imagine a bed sheet stretched out tight. Place a bowling ball in the center and you get a dip. That's gravity. Now imagine taking 2 points on that sheet, distant from each other, and pushing your fingers through them to create a tunnel. That tunnel is the wormhole. The term wormhole itself comes from a simple idea. Think of an apple. A worm wants to go from one side to the other. It could crawl across the surface, which takes time, or it could burrow straight through. The shortcut through the apple is the wormhole. In the same way, if you wanted to travel from Earth to a galaxy millions of light years away, a wormhole could, in theory, get you there almost instantly. That's the appeal. It's the ultimate shortcut through the universe. But here's where it gets tricky. Wormholes are not just sci-fi magic doors. They are solutions to Einstein's equations, yes, but they come with baggage, serious baggage. To hold a wormhole open, you'd need a form of matter we've never seen before: exotic matter. Not exotic like a tropical bird, but exotic in the sense that it has negative energy density. That's not something we just find lying around. Without it, the tunnel collapses faster than you can say, event horizon, snapping shut like a cosmic mousetrap. Now let's say, just hypothetically, that some advanced civilization or freak of nature manages to stabilize one. You're floating in space, and there it is, a wormhole, a swirling tunnel of distorted light and gravity. You enter. The inside wouldn't be like anything you know. Forget the stars, the silence of space. This is a realm where time bends, light curves, and direction loses meaning. You wouldn't feel gravity in the way you're used to. You might even find that seconds for you become years for someone outside. That's time dilation, something astronauts on the International Space Station actually experience, but in tiny doses. Inside a wormhole, that effect could be extreme. Here's a helpful way to picture it. Remember old tube televisions? If you put a magnet near the screen, the picture would warp and swirl, right? That's what gravity does to light and space itself in a wormhole. The structure isn't smooth. It's like a glass marble with cracks and bubbles, refracting reality in unpredictable ways. Navigating through that would be like trying to walk straight inside a funhouse made of moving mirrors while blindfolded. And let's talk about the never come back part. If a wormhole is unstable, and most of them would be, it might collapse while you're inside or right after you pass through. That means there's no way to retrace your steps. It's a one-way trip. Worse, some wormholes might not even lead to another place in our universe. They could connect to a different universe altogether, governed by different physical laws. Imagine entering a world where gravity pushes instead of pulls, where atoms behave unpredictably, or where time doesn't move forward. Would your body even function? Would your thoughts make sense? There's no manual for existence in an alien cosmos, and it's not just a question of physics, it's a philosophical mind bender. If you go through and can never return, did you really travel, or did you vanish? From our point of view, you'd be gone like a message sent into the void without a reply. And that's the haunting part. Wormholes tantalize us with the promise of cosmic adventure, but also warn us that the universe doesn't owe us a round trip. We're used to exploring with the assumption that we can come home. Wormholes might break that rule. So the next time someone tells you wormholes are cool, remember, they're also cosmic traps full of promise and peril. Like lighting a match in the dark, they show us the edge of what we know and dare us to step beyond. It was the 1930s, a time when the world was beginning to grasp just how strange the universe really is. Einstein, already famous for shaking the foundations of physics with his theory of relativity, teamed up with another brilliant mind, Nathan Rosen. Together, they proposed something that sounded like it was ripped straight from a science fiction novel, A Bridge Through Space and Time. The result of their collaboration was what we now call the Einstein-Rosen bridge, the earliest theoretical model of a wormhole. They weren't thinking about shortcuts through galaxies or cosmic portals at the time. Their goal was to understand how the fabric of spacetime behaves near something as extreme as a black hole. You see, black holes had just recently entered the theoretical conversation. They were weird and unsettling, objects so dense that not even light could escape. But Einstein and Rosen asked a deeper question. What happens on the other side of a black hole? Is it really the end, or is there something more? Their equations suggested that if you extended the math, you could imagine two black holes connected by a kind of tunnel, a wormhole. At first, the concept was treated more like a mathematical curiosity than a gateway to distant worlds. But that idea stuck, and decades later, it exploded into one of the most thrilling possibilities in theoretical physics. Flash forward to the late 1980s. Enter Kip Thorne, a physicist with a love for bold questions and a mind built for bending the rules of nature, at least on paper. Thorne was approached by his friend, Carl Sagan, who was writing a novel that would eventually become the film A Contact. Sagan wanted to know, is there any semi-scientific way a person could travel across vast interstellar distances, say, from Earth to the star Vega, in a reasonable amount of time? Thorne, intrigued, dove into the problem and realized that wormholes were the best bet. But there was a catch. Thorne's work showed that for a wormhole to be traversable, meaning someone could actually go in one end and come out the other without being instantly crushed, it would require exotic matter. That same bizarre substance with negative energy density that doesn't exist in any tangible way we can harness. Still, the theory held up, and it marked a turning point. Wormholes weren't just sci-fi anymore, they had some scientific legs to stand on, even if those legs were still very wobbly. To make the idea relatable, think of those explorers in the Age of Sail. Back in the 15th century, when people believed the ocean might drop off at the edge of the world, there were still sailors who dared to test it. They set out without maps, without any certainty of return, trusting only their understanding of wind and stars. A wormhole is the modern-day version of that mystery sea. If someone ever did step through one, they'd be like those early navigators, plunging into the unknown, with no clue what lies beyond, or if they'd ever return to tell the tale. And even though no one's ever found a wormhole, there's been real world progress in understanding the strange physics that might make them possible. Quantum mechanics, the theory that describes how the tiniest parts of our universe behave, has been playing a role too. In fact, some physicists now believe that wormholes and quantum entanglement, that spooky connection between particles Einstein himself doubted, might be linked. The idea proposed in recent years is called EREPR. It's a bold attempt to tie together gravity and quantum mechanics by suggesting that entangled particles might be connected through microscopic wormholes. No one knows if that's true, but it's a tantalizing thought. Maybe wormholes are everywhere, woven into the very foundation of reality. So from Einstein and Rosen's thought experiments to Kip Thorne's Hollywood-friendly physics to today's cutting-edge theories at the edge of imagination and logic, the story of wormholes is filled with bold thinkers chasing big questions. And if one day a brave soul does step into a wormhole and disappears into the fabric of the cosmos, it will be the continuation of a long journey. A journey that began not with spaceships, but with chalkboards and curiosity. Imagine this, the real twist about wormholes isn't just that they might let you travel across galaxies. It's that, under very specific, exotic, and highly theoretical conditions, they could let you travel through time. That's right, not just from point A to point B across space, but from ev now to then. Most people, when they think of wormholes, think of them as portals to distant places in the universe. But hidden in the math of general relativity is a mind-bending detail. If you manipulate a wormhole just right, you might actually be able to go backward or forward in time. Now, how does that even work? The explanation begins with a wild property of time itself. It's not the universal, steady, flowing river we tend to think it is. Time, according to Einstein, is stretchy. It can dilate, it can contract, it can be warped. So, if you had a wormhole and moved one end of it at near light speed, then brought it back to its original position, you would have created a time difference between the two ends. In other words, you now have a tunnel not just between two places in space, but between two times. Step into one side and you might emerge not just somewhere else in the cosmos, but somewhere else entirely. This isn't just poetic metaphor. Physicists have seriously studied the concept. Kip Thorne and his colleagues didn't just theorize about wormholes for fun. They published detailed academic papers exploring whether traversable wormholes could become time machines. What they found was fascinating. The laws of physics as we know them don't actually forbid this. There's no giant red X saying it's impossible. Instead, the universe just whispers a soft maybe. It's not likely, it's not proven, and it certainly isn't easy, but the door is cracked open. And here's the part that really stirs the imagination. If someone went through a wormhole that was rigged as a time tunnel and they couldn't come back, it might not be because they were flung across space. It might be because they were tossed out of their own Veera. They could be somewhere in the past, before humans ever walked the Earth. Or in the distant future, watching stars fade into darkness billions of years from now. It's not just about distance, it's about chronology. That's the twist most people miss when thinking about wormholes. They're not just space benders. They're potentially time weavers. This leads to all sorts of intriguing consequences. Could someone actually meet their past or future self? Would history unravel? Would the universe stop them with some kind of cosmic censorship, a built-in mechanism to prevent time paradoxes? Stephen Hawking thought about this too. He proposed something cheekily called the chronology protection conjecture, which basically says the universe doesn't allow time travel to mess with causality. If you try to build a time machine, something always goes wrong, radiation builds up, energy destabilizes the wormhole, or space-time just says nope and slams the door shut. But that hasn't stopped physicists from poking at the idea, testing it, running simulations, and exploring theoretical models. One little known model even suggests that baby wormholes, tiny quantum ones, might spontaneously appear and disappear at the smallest scales of reality, all around us, all the time. They're called quantum foam, wormholes, and they'd be so small you'd need a microscope the size of a galaxy just to see one. But they're baked into the math of quantum gravity. Some researchers even think these tiny wormholes could be part of the reason particles seem to instantly influence one another across space. If true, it changes everything we know about how information and energy move in the universe. So when you hear someone say, "What if you enter a wormhole and never come back?" the answer might not be what you think. Maybe they didn't vanish into the black void of a distant galaxy. Maybe they slipped into the timeline like a leaf carried down a different stream. Maybe the reason we never see them again isn't because they're lost, but because they're no longer in the same now as us. When we ask what might happen if you enter a wormhole and never come back, we're not just playing with theoretical physics. We're leaning into one of the oldest, deepest instincts of the human experience, to the urge to cross the boundary, to peer behind the curtain of the known, to wonder what lies beyond the edge of the map. And in that sense, the wormhole isn't just a strange tunnel carved through the fabric of spacetime. It's a metaphor for all the doors we've ever stood before and dared to open. The frontier has always called us, whether it was the uncharted oceans, the void of space, or the strange terrain of subatomic particles. There's something in us that refuses to stop at the border of mystery. That same impulse is what drove early astronomers to sketch the stars and name constellations. It's what inspired Galileo to lift a telescope to the night sky, not knowing whether what he saw would confirm his beliefs or destroy them. And it's what pushes today's physicists to run particle collisions and map gravitational waves, looking for clues that might crack the cosmic code. So, when we talk about wormholes, we're not just indulging in science fiction. We're participating in that long, noble tradition of not settling for what's easy to understand. And let's be honest, it's not easy to accept the idea that space and time might be warped, or that there could be shortcuts between stars, or that you might disappear into one of them and never return. But then again, the universe has never asked for our comfort. It just is strange, vast, unpredictable, and yet somehow comprehensible, at least in part. Wormholes might never be proven real, or they might exist in some distant corner of the cosmos, curled up in quiet. But either way, they stretch our thinking beyond everyday limits. They ask us to imagine a reality where movement through space and time is not linear but looped, flexible, even artful. And when we imagine someone stepping into a wormhole and not returning, we're forced to ask a bigger question, one that goes far beyond physics. What does it mean to go into the unknown and leave the familiar behind? Isn't that what every explorer, every scientist, every dreamer does? Whether it's sailing across an ocean, launching a spacecraft, or delving into the equations of relativity, there's always that moment when you leave behind certainty. When you don't know if you'll come back, or what will have changed if you do. That's the real heart of the question. Not just where a wormhole might take you, but what you're willing to risk to find out. It turns out that even asking, "What if you never come back?" reveals something fundamental about who we are. We are the species that ventures. We are the minds that seek. And even if the path forward is a one-way trip into mystery, we'll take it not because we expect comfort or answers, but because we cannot do otherwise. Something in our nature propels us to chase the unknown, to challenge the boundaries of existence, to bend toward truth like plants to sunlight. In that way, a wormhole is not just a theoretical curiosity. It's a reflection of our greatest aspirations and our deepest fears. It's the ultimate test of what it means to be conscious beings in a vast and complex universe. It reminds us that knowledge is not always safe, that truth can be beautiful and terrifying in equal measure, but also that the journey is worth it, not because we know where it leads, but because it leads somewhere we've never been. Somewhere far beyond our reach, beyond the twinkling lights we call stars, past the swirl of galaxies dancing to gravity's silent music, there may be a tunnel, invisible to our eyes, hidden in the fabric of space like a secret thread in a cosmic tapestry. A wormhole, a whisper of possibility where the laws of physics don't forbid it, but instead lean back, arms crossed, and say, "We can't stop you, but good luck." It's a place where distances collapse, where time stretches and folds in on itself like origami, and where the destination might be another galaxy or the edge of existence itself. It's not fantasy. It's not magic. It's just the cosmos daring us to dream a little bigger. And yet, the moment you step toward that threshold, toward that impossible portal, you're faced with a profound question. Not just, where does it lead? But who do you become when you cross it? Because venturing into a wormhole, or even imagining it, demands more than mathematical equations or theoretical physics. It asks for courage, for imagination, for the kind of curiosity that burns quietly but endlessly in the human soul. It demands that we let go of certainty and embrace wonder as a guiding force. Even our thoughts about wormholes, speculative as they are, serve a greater purpose. They expand our minds. They make us ask questions we didn't think we were allowed to ask. Questions about what space is, about what time is, about whether the universe is a place we live in or something we're woven into. And in that asking, we grow. We evolve. We look into the sky not just for answers, but for meaning. And that's the beauty of it all. The universe doesn't need to be full of answers for us to keep asking. It simply needs to exist, and that's enough to spark an infinite number of questions. When you think about traveling through a wormhole and never coming back, you begin to see the reflection of something deeper. It's not about the physics anymore. It's about the essence of exploration. The willingness to take the first step into darkness, trusting that even in the unknown, there is something worth finding. That same impulse built civilizations, launched telescopes, inspired symphonies, painted galaxies on ceilings, and etched equations onto chalkboards. It's the same spark that's in the child looking through a telescope for the first time. The same fire behind every "what if" that refuses to be silenced. If we ever did find a wormhole, and if someone ever crossed its threshold and didn't return, it would not be a tragedy. It would be a continuation of what we've always done, sending pieces of ourselves into the abyss so that one day, someone might understand just a little more. Like messages in a bottle cast into the cosmic ocean. Our thoughts, our dreams, our questions become part of the universe's grand conversation. And what a privilege it is to take part in that dialogue, to be conscious creatures in a universe that lets us wonder. There's poetry in the idea that the universe hides shortcuts in its very structure, that perhaps we are not meant to stay still. That maybe, just maybe, the cosmos wants to be discovered. And if that's true, If even space and time bend to the will of curiosity, then what excuse do we have not to follow that thread wherever it leads? The stars will not come to us, but we can reach for them. And in reaching, we don't just move through space, we transform ourselves. We become more than observers. We become participants in the unfolding story of the cosmos. Our questions, our risks, our willingness to explore, even blindly, are the verses we contribute to that story. So if you ever find yourself standing before something strange and unknown, like a wormhole or an unsolved mystery or a truth too vast to hold, don't run. Don't fear it. Lean in. Ask the question. Follow the thought. Cross the threshold. Because the moment we stop being afraid of not coming back, we become something greater than ourselves. We become explorers not just of the stars, but of truth and time and the very nature of being. And that, in the end, is how we come to know the universe, not by staying where it's safe, but by walking straight into the cosmic unknown with our eyes wide open and our hearts burning with wonder.